Mutually exclusive and inclusive events. Let's get started. Lesson 2.5.1 Mutually exclusive, inclusive events. By the end of the period, with at least 80% mastery, students will be able to explain the difference between a mutually exclusive and inclusive events and find the probability of mutually exclusive and inclusive events. Definition for mutually exclusive events. Two events are mutually exclusive if they cannot occur at the same time. That is, they have no outcomes in common. Examples of mutually exclusive events are turning left and turning right, tossing a coin, getting heads, tails. In cards, kings, and aces. Definition number 2, mutually inclusive events. Two events are mutually inclusive or not mutually exclusive if one event can happen at the same time as another event. Examples of mutually inclusive events are turning your head left and scratching your head. So you can do this at the same time. In cards, you can have king and hearts because in hearts there is a king. So at the same time, you can have a king and hearts. Determine which events are mutually inclusive when a single die is rolled. Getting an odd number and getting an even number. So this is mutually exclusive. You cannot have an odd and at the same time an even. Getting a 3 and getting an odd number. So this is mutually inclusive because a 3 is an odd number. Getting an odd number and getting a number less than 4. So this is mutually inclusive because a number less than 4 can be 1, 2, and 3. And 1, 3 are odd numbers. So getting an odd number and getting a number less than 4. Determine which events are mutually exclusive and which are mutually inclusive when a single card is drawn from a deck. Getting a 7 and getting a jack. So this is mutually exclusive. You cannot have a 7 at the same time a jack. Getting a club and getting a king. So a club can have a king. Therefore, this is mutually inclusive. Number 3, determine which of the following events are mutually exclusive and which are mutually inclusive. Letter A, being overweight and having blood pressure. It is possible that when you are overweight, you have blood pressure. So mutually inclusive. Being a U.S. senator and being a member of the House of Representatives at the same time. So mutually exclusive. You cannot be a U.S. senator at the same time a member of the House of Representatives. Addition rule 1 for mutually exclusive. When two events are mutually exclusive, the probability that A or B will occur is probability A or B equals probability A plus probability of B. Example number 4. A restaurant has 3 pieces of apple pie, 5 pieces of cherry pie, and 4 pieces of pumpkin pie in its dessert case. If a customer selects a piece of pie for dessert, find the probability that it will be either cherry or pumpkin. So probability that is here cherry or pumpkin equals P or probability of pumpkin plus probability of cherry, where for cherry we have 5 over 12 plus for pumpkin 4 over 12. So final answer is 3/4. Letter B, it will be either apple or pumpkin. So probability that it will be apple or pumpkin equals probability that it will be apple plus probability that it is pumpkin. So probability of apple is 3 over 12 plus probability of pumpkin 4 over 12. So this is equal to 7 over 12. Number 5. At a political rally, there are 20 Republicans, 13 Democrats, and 16 Independents. If a person is selected at random, find the probability that he or she is either a Democrat or an Independent. So probability that he is a Democrat or Independent is P Democrat plus P Independent equals 13 over 39 plus 6 over 39, which is equal to 19 over 39. Letter B, a Democrat or Republican. PD or I equals PD plus PR. So this is 13 over 39 plus 20 over 39 equals 33 over 39 or 11 over 13. Number 6. A day of the week is selected at random. Find the probability that it is a weekend day. So weekend, Saturday or Sunday. Saturday or Sunday equals probability it's Saturday plus the probability is Sunday. So this is 1 over 7 plus 1 over 7 equals 2 over 7. Now addition rule number 2 for mutually inclusive events. If A and B are mutually inclusive events or not mutually exclusive, then the probability that A or B equals probability A plus probability B minus probability A and B. When two events are not mutually exclusive, we must subtract one of the two probabilities of the outcomes that are common to both events, since they have been counted twice. Let's look at example number 3. Card is drawn randomly from 9 cards labeled 1 through 9. What is the probability of picking a number less than 4 or a 2? So the probability of picking a number, by the way, we have these outcomes here, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the probability that it is a number less than 4 or 2 equals. So probability less than 4 is 3 over 9 plus probability it is a 2 is 1 over 9. But we have counted 2 times. So subtract minus 1 over 9, which is 3 over 9 equals 1/3. Letter B. Find the probability of getting an odd number or a number less than 3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Probability that it is an odd number is 5. There are 5 of them. 1, 3, 5, 7, and 9. So 5 over 9 plus. Less than 3, there are 2 numbers. 1 and 2, so 2 over 9. Minus the odd number that we have counted 2 times is 1. So 1 over 9. So therefore, this is 6 over 9 or 2/3. A single card is drawn from a deck. Find the probability of selecting the following: a 4 or diamond. So this is an example of a mutually inclusive events because you can find also a 4 in diamonds. So probability that it is a 4 or diamond equals probability that is a 4 plus probability that it is a diamond minus the probability of a 4 of diamonds. So probability that is a 4 is 4 over 52 plus there are 13 diamonds, so plus 13 over 52, but we have counted for 2 times. So minus one of those, minus 1 over 52 equals 16 over 52 equals 4 over 13. A club or a diamond. So this is not mutually inclusive because they are separate. Therefore, we have probability that is a club is 13 over 52 and diamond is 13 over 52. So we have total is 1/2. A jack or black card. Is this mutually exclusive or mutually inclusive? Yes, it is mutually inclusive because you can find a jack in a black card. So, probability is a jack or black card equals probability of a jack plus probability of a black card minus the probability of a jack of black card, which is equal to 4 over 52 plus 26 over 52. 26 over 52, there are 26 black cards. So 26 over 52 minus 1 over 52 because we have already counted the jack 2 times equals 29 over 52. In a statistics class, there are 18 juniors and 10 seniors. 6 of the seniors are females and 12 of the juniors are males. Complete the following table, then answer the questions that follow. So there are 18 juniors, therefore that is 18 there. 10 seniors, so we have 10 seniors here. 6 of the seniors are females, so 6 seniors are females. 12 of the juniors are males, so males. So we can find how many males in seniors, or how many male seniors. Since there are a total of 10 and 6 females, therefore there are only 4 males. And we can find the sum of these males here for the juniors and seniors. 12 plus 4 equals 16. Also, since there are a total of 18 juniors and 12 of them are males, therefore there are 6 female juniors. So if we add all the females, we have 6 plus 6 equals 12. And then the total is 18 plus 10 equals 28, or the total here for males and females is also 28. Now we are ready to answer the question. If a student is selected at random, find the probability of selecting the following: a junior or a female. So, junior or female is equal to the probability that it is a junior plus the probability that it is a female minus the probability that it is a junior female. So probability that is a junior is 16 over 28. Female, 12 over 28 minus the probability that a junior female is the intersection of these two lines here, which is 6, so minus 6 over 28. That's why we subtract 6 over 28. So the final answer is 6 over 7. A senior or a female. So senior or a male equals probability that is senior plus probability it's a male minus the probability that is a male senior. Probability that the senior is 10 over 28. Probability that is a male is 16 over 28 minus the intersection of senior and male, which is 4 over 28. So this is equal to 11 over 14. Probability that is a junior or a senior is mutually exclusive because a junior cannot be a senior or a senior cannot be a junior. Therefore, this is probability is junior plus probability senior equals 18 over 28 plus 10 over 28 equals 1. If there are no more questions, then let the students complete the classwork sheet until the end of the period. Have a nice day.